Hey there, y'all. Today we're going to look at 1.5 on graphing linear inequalities. And in this section, we're going to be able to graph and apply linear inequalities. This is some stuff that we looked at in Algebra 1, but we're going to continue here in Algebra 2. And so the standard that we're looking at is ACE.3, and that is to be able to use systems of equations and inequalities to represent constraints arising in real-world situations. That's what we're building to with the standard. And so when we get to Section 6 and Section 7, we're going to look at how to use systems, but this section builds us to that today. And so we're going to look at example 1. All right, so here we have given graph x minus 2y is less than or equal to 4. And so this is given in standard form, and so we can do one of two things with this graph. We're first going to either want to get it into slope-intercept form, so we can graph it easily that way, or we're going to want to find the intercepts to graph this out of standard form. And so if I want to find the intercepts, so x minus 2y less than or equal to 4, for the line itself, we can pretend that this is an equal sign for a minute, and then we'll deal with where the shading and what type of line it is. So if I'm looking for the x-intercept, remember that the x-intercept is an order pair x comma 0. And so I'm going to plug in 0 for the y, and I get x minus 2 times 0 is equal to 4. And again, we're changing to an equal to here just to get the line itself. We'll deal with the shading in a minute. 2 times 0 is 0, so I get that x is equal to 4. And so my x-intercept is 4. And then we'll look at the y-intercept, do the same thing. For the y-intercept, remember we're going to do 0 comma y. And so when we do that, we're going to get 0 in for the x, minus 2y is equal to the 4. And so that cancels, so we get negative 2y equals 4, divide by the negative 2, and we get that y is equal to negative 2. And so that gives me my second point, which is the y-intercept of negative 2. Now be careful here. These are two separate points, and I want you to see that. That's why I did the x in blue, the y in red, so that way we know it is two separate ordered pairs. We found the x-intercept and the y-intercept. Now that we found these two ordered pairs, we can draw the line. This comes back to our inequality. And this is where we need to understand what type of line we draw and where the shading will go. So remember that if it is anything with an equal to bar underneath, or just an equal to sign, we're going to draw a solid line. And so I'm going to continue my slope here. This is up 2 and right 4, so up 2 and right 4. And then from here I can go down 2 and left 4, just reversing both directions. Down 2 and left 4 again to here. And so if it is any type of equal to, the line will be solid. So again, if it is less than or equal to, greater than or equal to, or just a regular equal to, right, all those will be a solid line. If there is no equal to, then we're going to do a dashed line as we go across, and we'll look at that in the next example. So this line will be solid as we go all the way across here. Now, your other teachers might have told you different ways to shade this, and some might say look at the inequality, some might say test a certain point. I'm going to tell you to test a certain point. And the best point to test is the origin. If the origin is not along that line, 0, 0, right? If the origin is not along the line, test that point. Because what we want to see is, does this point satisfy the inequality, or does it not satisfy the inequality? Because if it does satisfy, we're going to shade on that side of the line. And if it doesn't satisfy, we're going to shade on the other side of the line. And so when I test this, I get 0 minus 2 times 0. Is that less than or equal to 4? Well, 0 minus 2 times 0, so that's 0. Less than or equal to 4. Is 0 less than or equal to 4? Yes, it is. And so this point checks out. And so my graph will be shaded all on this side of the line because that is where 0, 0 is. I do not want you to get stuck up on if it's above or below the line. Now, we'll talk about that in terms of describing it, but when it just comes to shading it, I want you to understand that above or below doesn't mean anything. Does the value work or does it not is what we really need to look at. So let's talk about what this final solution means. So we see the shaded region there. Any point that I can have in this shaded region, so I could pick here, I could pick here, I could pick here, any of these points in this shaded region will be a solution to the inequality when we plug in the x and the y value for that point. Because this line is solid, also any point along this line, and it does not have to be one that crosses through a corner, it could be like, for example, this point here, which would be at 6, 1/2. That is also a point that is on the line and would be a solution to the system because it is less than or equal to. Now again, you're thinking less than. Why is the shading above the line? That's the issue. If you just look at the inequality symbol, you're going to get confused. You're going to mess this up, and I need you to pay attention. Try the order pair and get it that way. Don't just look at the inequality and be like, oh, it's going to go this way because it's a certain inequality. Don't do it. So let's look at example B here. We've got 2x plus 5y is greater than 10. And so in this example, I'm going to show you how to rewrite it into slope-intercept form. And remember that is y is equal to mx plus b form, right? And so we're going to rewrite this so that we can get it that way. We can find the intercept, we can find the slope, and graph it that way. So if I've got 2x plus 5y is greater than 10, my entire goal is to get this y value by itself. And so our first step will be to move the entire x. And so in this case, I'm going to subtract 2x from both sides. This will cancel. And so I get that 5y is greater than negative 2x plus 10. So again, 5y greater than negative 2x plus 10. Now to get the y by itself, I need to divide both sides by 5. And so I'm going to divide by 5 here, and divide by 5 here, and divide by 5 here. Again, remember, what you do to one side, you have to do to the other side, which is why it has to divide to every term on both sides. Okay, and so this will cancel. And so I get that y, we divided by a positive, so the inequality will not flip. Y is greater than negative 2/5 x plus 2. Okay, that's as far as we'll get reduced, and so that's what we'll do from there. So my y-intercept is 2. So my b is equal to 2. My slope is negative 2/5. And so I'm going to start with my y-intercept at 2. And I'm going to go down 2 and right 5. So again, y-intercept at 2, go down 2 and right 5 to get there. Now, remember in the previous problem we said that if there was any type of equal to, we would do a solid line. Less than or equal to, greater than or equal to, or just straight equal to. It's a solid line. If I don't have that equal to part, so in this case this is just greater than, or if I just had less than, when I just have those two symbols, the line will be dashed. Okay? And so in this case, we're going to take this, and I'm going to continue my slope so I can get a better line here. So I'm going this way down and right. Here I'm going up and left, and then up and left one more time. And so, and again, this line will be dashed, and my pen is just messing up just a little bit here. But the line is dashed. It's not connected. Okay? And so what's going to happen is any point that is along this line will not be a solution to the final answer. So, for example, the y-intercept of 0, 2 will not satisfy this inequality because if I plug in 0, 2, I end up with 10. And 10 is not greater than 10. And that's why it's not a solution. Now, go back to the previous problem. We talked about plugging in a certain point. I still want to plug in 0, 0 to the original inequality and see what happens. So when I plug in 0, 0 to this, so I get 2 times the 0 plus 5 times the 0. Is that greater than 10? Well, 2 times 0 is 0, and 5 times 0 is 0, and 0 plus 0 is 0. So is that greater than 10? Definitely not. And so when I look at this point of 0, 0, I'm going to put a little x next to it because it is not a solution in this case, right? So in this case, I'm going to shade the opposite side of the line. So again, if the point doesn't work, we shade the opposite side of the line. If the point works, we shade that side of the line. And so with this one, we're going to shade all up here. And everything above this dashed line will be a solution. And so Any point in that blue shaded region is a solution. Any point on the orange dashed line in this case is not a solution. So again, anything just above it will work. Anything on it won't. Anything below it definitely doesn't, right? Because we tested 0, 0 and it doesn't work. So moving on to example 2, we're going to look at how to solve a problem with a constraint. And so the problem says this. One tutoring company advertises that it specializes in helping students who have a combined SAT verbal and math score of 900 or less. We want to write an inequality to describe the combined scores of students who are prospective tutoring clients. Let X represent the verbal score and Y the math score, and we're going to graph this inequality. And so when we talk about having a combined score, let's talk about picking out the important pieces here. We want a combined score. Well, what operation sounds like it would be combined? Addition, right? So whatever's happening, I'm taking the verbal score plus the math score, and it wants the score to be what? Of 900 or less. Okay, so whatever happens here, this addition has to be 900 or less. Well, what inequality is going to represent that? Well, obviously it's got to be less, so it's less than, but can it be 900? Well, it's like it can be 900 or less. So yes, it can be equal to the 900, and so we'll see that there. Now, they gave us some variables for this, so verbal is X, and the math is Y, and so this becomes our inequality. Now we want to graph it. Now, can we graph this by hand? Sure. This is actually a really quick and easy one to graph. Again, this would be better by intercepts. And so we're going to see here 900, and over here 900, and this is our X for the verbal, and this is our Y for the math score. And if I plug in 0 for Y, that means my my X-intercept is at X comma 0, right? And so when I put that 0 there, I get X is 900. So my X-intercept is 900. And when I do the same for the Y, I get that the Y-intercept is 900. It is equal to, so my line will be solid, and I will draw this line. Now let's talk about the shading. Will the ordered pair 0, 0 work here, right? So if I try 0, 0, that's the origin. 0 plus 0 is that, and again I apologize for my pen, less than or equal to 900. Well, 0 is definitely less than or equal to 900, so it checks. So this point here checks out, which means everything this side of our line will be shaded. And so any combination of verbal and math scores that would be in this orange shaded region would be a solution. Now, why did I not draw this in 4 quadrants? Well, think about SAT scores. Can an SAT score be negative? No. It actually ranges from 200 to 800. So there's more constraints that would actually fall on this problem than we've put in. And we'll talk more about those when we get to section 7 about how we could restrict certain areas. But that's what we're looking at here just on a general basis. So to give you a little preview of that, I've given this graph here. And so you'll actually see we still have that red line going across the middle right here that would eventually reach up and get to 900, right? But you'll see that this does not get all the way down to 0 and 0 because, again, the math and verbal scores on an SAT did not reach 0. They stopped at 200. And so that's why we see this graph just in this little triangular region here. But again, that'll be something that we look more at in section 7. And so let's look at part B here. Does a student with a verbal score of 480 and a math score of 410 fit the tutoring company's guidelines? And so let's go back over to that graph we just drew a moment ago, which has everything laid out for us. So where would that score, a verbal of 480 and a math of 410? So a verbal of 480 and a math of 410 would be right there. Is that within our shaded region or on this line? And would the student be eligible for the tutoring program? We'll see that yes, it is just below the line, right? Now we can verify this by plugging into the inequality as well. And so we can do 480 plus 410. Is that less than or equal to the 900? And we get 890 is less than 900. So yes, the student would be eligible. Okay, So that's what we've got there. Again, not complicated, but just got to understand what your graphs are saying. We got one more example we're going to look at, and we're going to look at this class trip for a couple of math classes. So 2 math classes are going on a field trip. The teachers have requested parent volunteers to also go to be chaperones. However, there's only enough seating for 55 people on the bus. Write an inequality to describe the number of students and the number of chaperones that can ride on the bus. And so if we use S for students and C for chaperones, which pairing is going to give us the appropriate way that these people can sit on the bus? So obviously we need to add together how many people are going, but which equality symbol would it be? Well, think about what this says. So the number of students plus the number of chaperones can be greater than or equal to 55. So I can put 56 or 60 or 65 people on a bus. Does that make sense? Not really, right? So we look at S plus C is less than or equal to 55. So that means the number of students plus the number of chaperones is that less than or equal to 55. Well, that would kind of make sense, right? Because I could have 50 people on this bus, right? And this says I could have 55 people, right? Because it's equal to as well. So that's a possibility. Let's hold on to that one for a second. We know it's not going to be A because we can't put more people on a bus than the bus will fit, right? So S plus C is less than 55. That's option C. So that one's also a possibility, right? Because, again, I could have 50 people on a bus. So that makes sense. And the last one, S plus C is greater than 55. Well, again, that's like case A, except it's not equal to. So, again, we can't have more than 55 people on a bus. So the question is, can I sit 55 people on the bus? And we go back up here, there is only enough seating for how many people? 55. And so the correct answer here is B. Now, let's go to part B. Can you fit 10 chaperones and 47 students on this bus? So we could graph this and see where the shading is. And again, if we were to graph this out with students and chaperones, this is very simply, we'll have 55 here and 55 here, students to chaperones, and it will look like this. And then 0, 0 would work, so all my shading would be down here. And so we want to know 10 chaperones, 47 students. Will that work? Well, again, we could use like Desmos or another program to graph this, but 10 chaperones, 47 students is going to lie right here, because 10 plus 47, is that less than or equal to 55? No, because 57 is not less than 55. So no, this combination will not work. And remember, that word problems require word answers. And so make sure you're writing a sentence or something to complete the thought of what we're doing in these problems. So that's section 1.5 on graphing linear inequalities. Again, if you have questions, make sure you put them in the Google form or make sure you ask them in class. But that is it for this lesson, and I'll see y'all next time.